Good day, ladies and gentlemen. Welcome to Code Switch in 2020. Today we continue with our grade 12 mathematics, looking at the rules of differentiation. So, as we have said in previous videos, please know the notations. We have four notations. It's f prime of x, dx, d over dx, dy over dx. So once you see these notations, please be mindful that to find the derivative. So we'll be finding the derivative using the four rules, where rule number one states the following: the derivative of a constant is always 0. Derivative of f of x, where x has an exponent n, you multiply the coefficient with n and you subtract 1 on the exponent. Rule number 3 states that if you have a coefficient of x exponent n, you still multiply n with the coefficient and you subtract 1 on the exponent. So rule number 4 states the following: the derivative of f of x plus minus g of x, you find the derivative of each term using the above rules. If it's 0, if the derivative is constant, you put 0. If f of x is exponent n, you use rule number 2. If f of x is k multiplied by n exponent n, you use rule number 3. So, without any waste of time, let's look at today's examples. We'll be solving the 5 example. Please, if you understand or have a bit of understanding in terms of how to find the derivative, please pause the video, try them out, and then continue the video. So without any waste of time, they say evaluate number 1, dy over dx if y equal to 2x squared plus 2x minus 4 all divided by 2x minus 2. Number 2, evaluate dv over dx if v equals to x minus 4 over the root of x. Number 3, ds over dv if s equal to 2v squared plus 1 over 3v exponent 9 minus 4q. And number 3, dy over dx if xy equals to x cubed plus 1 minus y. Number 5, evaluate f prime of x if f of x equals to negative 4x cubed plus 6 the root of x. So let's look at number 1. Number 1 states the following: evaluate dy over dx if y equal to 2x squared plus 2x minus 4 all divided by 2x minus 2. So as I have said that before you find the derivative, you need to simplify. If you are given the brackets, you expand the bracket. If you have the root, you make the root to be an exponent. And if you have a fraction where x is the denominator, you write it as an exponent with negative exponent. So in this case, we will need to factorize first before you find the derivative. Then we simplify y will still be equal to the first method of simplifying will factorize, and first question is, do we have the common factor? Yes, we have a common factor of 2. Then we will be taking 2 out as a common factor. We'll be left with x squared plus x minus 2 on the numerator. On the denominator, we also see 2 is a common factor. We'll take 2 out. We'll be left with x minus 1. We'll be left with x minus 1. So 2 cancel out. We are left with x squared plus x minus 2 all divided by x minus 1. Then we see on the numerator we have a quadratic function which we can simplify by factorizing. We'll have x plus 2 into x minus 1 all divided by x minus 1. This is still y. Therefore, y will be equal to x minus 1, cancel out x minus 1, will be left with x plus 2. Therefore, what is dy over dx? Derivative of x will be 1. Derivative of a constant is 0. Therefore, dy over dx is 1. So it's very important for you to simplify the equation that you are given before you find the derivative. Let's look at number 2. Number 2 state the following. Evaluate dv over dx if v equals to x minus 4 over the root of x. So please be reminded that if they say find, for example, dv over dx, it means our equation will be written as v. If they say find dy over dx, it means our equation, the subject of the formula, is y. Here the subject of the formula is v. If they say find dk over dv, it means the subject of the formula will be k with respect to v. So if they say find dv over dx if v equal to x minus 4 over the root of x, we need to simplify this one first so that we'll be able to apply the rules. So v is the same as, since the lowest common denominator is the root of x, this will be the same as x over the root of x minus 4 over the root of x. So this will still be the same as x over, I said if we have the roots, we simplify it as an exponent. This is x exponent 1 over 2 minus 4 multiplied by x exponent negative 1 over 2. So when you divide powers with the same base, we subtract the exponent. When you simplify this, it becomes x exponent 1 minus 1 over 2 minus 4 multiplied by x 4 multiplied by x exponent negative 1 over 2. So it means v will be equal to x exponent x exponent 1 minus 1 over 2, it's 1 over 2 minus 4 x exponent negative 1 over 2. So we haven't found the derivative yet, we're just simplifying our expression. So now let's find dv over dx. We need the derivative of v with respect to x. We apply the rules. This will be x exponent 1 over 2, you multiply the exponent with the coefficient, it becomes 1 over 2 x exponent 1 over 2 minus 1. If we have negative 4 x exponent negative 1 over 2, we multiply 1 over 2 with negative 4, it becomes 2x this will be 2x, then we subtract 1 on the exponent, 1 and negative 1 over 2 minus 1, it becomes negative 3 over 2. So this is plus 2 exponent negative 3 over 2. So let's simplify it. This is 1 over 2 x exponent 1 over 2 minus 1 is negative 1 over 2 plus 2. If we want to x exponent negative 2 over negative 3 over 2. So if we want to simplify the negative exponent, this will be 1 over 2 the root of x plus, this was negative, 2 over x exponent 3 over 2. This is how to find dv over dx. So as I've said, you simplify the expression, then after you apply the rules. Let's look at number 3. On number 3, if they say find ds over dv, if s equals to 2v squared plus 1 over 3v exponent 9 minus 4q. So we want the derivative of s with respect to v. When you look at our equation, it's already simplified, so we just need to apply the rules. So when we have 2v squared, the derivative becomes the exponent multiplied by 2 becomes 4v minus 1 on the exponent, then becomes 4v. This is 4v. This is ds over dv. Derivative of 1 over 3 of 1 over 3 v exponent 9. The exponent multiplied by the coefficient, this becomes 1 over 3 multiplied by 9 is 3v minus 1 on the exponent, 3v exponent 8. This is positive 3v exponent 8. So we need the derivative of s with respect to v. Anything that is not v here we have 4q, we take it as a constant, meaning 4q will be our constant, meaning this will be minus 0. Therefore our derivative is 4v plus 3v exponent 8. So that will be all for number 3. Let's look at number 4. Number 4 state the following: determine dy over dx if xy equals to x cubed plus 1 minus y. So we need to find the derivative of y with respect to x. And as I have said that if they need dy over dx, it means y is the subject of the formula with respect to x. So we must simplify our expression so that y is the subject of the formula. So we'll start by transposing negative y to the left hand side. Then this will be xy plus y, which is this y. We'll be left with x cubed plus 1. We take y as a common factor. We'll be left with x plus 1 equal to x cubed plus 1. And we divide both sides by x plus 1, x plus 1. Therefore y will be equal to x cubed plus 1 divided by x plus 1. Then on the numerator we see that x cubed plus 1 is the sum of 2 cubes, and to factorize the sum of 2 cubes, if we have a cubed plus b cubed, you take the cube root of a, it becomes a, plus the cube root of b becomes b, Then you take the first term, you square it, becomes a squared. If it's positive, you write minus. You multiply the two terms, becomes ab. The last term is always plus. Then you take the second term, you square it, then becomes b squared. This is how to factorize the sum of two cubes. So the cube root of x is going to be x. The cube root of 1 is plus 1. X squared is x squared. If it's plus, becomes minus. 1 times x becomes x. Then last term is always plus. You square 1, becomes 1 squared. All this divide by x plus 1. So far we haven't found the derivative. We are just trying to simplify what we are given. Then x plus 1 cancel out x plus 1. Our y will be equal to x squared minus x plus 1. Then now we can find dy over dx using the rules. Derivative of x squared is 2x. Derivative of x is 1. Derivative of a constant is 0. So now we have 2x minus 1 as the derivative of xy equal to x cubed plus 1 minus y. So always try to simplify what you are given, then after apply the rules. Let's look at number 5. On number 5, they say evaluate f prime of x if f of x is given by negative 4x cubed plus 6 the root of x. As I've said that when we are given the root, you must write it as an exponent. This is the same as negative 4x cubed plus 6x exponent 1 over 2. This is our f of x. So if we need f prime of x, we apply the rules. F prime of x will be equal to the derivative of negative 4x cubed. You take the exponent, you multiply by the coefficient, becomes negative 4 multiplied by 3x. You subtract 1 on the exponent, becomes 2. Negative 4 times negative 4 times 3 is negative 12 x squared. So this is negative 12 x squared. Derivative of 6x exponent 1 over 2. You take the exponent, you multiply by the coefficient, becomes 6 multiplied by 1 over 2 x exponent 1 over 2. You subtract the exponent by 1. So 6 multiplied by 1 over 2 is 3x exponent negative 1 over 2. Then here we have plus 3x exponent negative 1 over 2. If you want to simplify the negative exponent, this is negative 12 x squared plus 3 plus 3 over the root of x. This is how to solve f prime of x if f of x is negative 4x cubed plus 6 the root of x. Thank you for watching. For more videos, please go to Code Switching 2020. Thank you.